7.22, how do functions change? So previous lesson we did average rate of change. This lesson we're going to investigate those average rates of change and their functions, right? So a car travels at 10 t squared feet in the first seconds after moving. Calculate the average velocity. Okay, so they're giving us a time. So we have delta D over delta T. Right, so that's distance over time. We know we have a time of 4 to 3. How do we get D? You actually have to plug it into the equation. So we actually have to plug in, 4. 4 squared is 16 times 10 is 160. 3 squared is 9 times 10 is 90. So we actually have to plug in 4 and 3, right, into the function, square it, and then multiply by 10. So once we get those, we can then say, this is 70 over 1 or 70, feet per second. Okay, looking at the next one, if we go to 3.1 minus 3, and we plug those in, obviously 3 is 90, so that's easy, right? But it gets a little harder when you have a decimal here, right? So you might need a calculator in the sense of go 3.1 squared times 10, you should get 96.1. So we get 6.1 over 0.1 or 61 feet per second. Okay, so we do this again. 3.01 minus 3. We know that's 90. Again, 3.01 squared is times 10 is 90.6. So this is going to be 0.6 over 0.01 or 60. Right, again, we could go 0.1, right? If you wanted to keep going, if you didn't round. Okay, same thing, 3.001 minus 3, minus 90. Okay, and then 3.001 squared is 90.06. So this is 0.06 over 0.001 or 60, right? So again, you could keep going, right? You could do this from both sides. 3 minus 2.99. So 90 minus, again, 2.99 squared. Times 10 is 89.401. So this would be 90 minus 89.401 is 0.599 over 0.01 or 59.9. Right, you get the gist, right? Estimate the exact value of the car. Well, what is this approaching? We've understood limits now. We're approaching 60 feet per second. Okay, use the graph. Now let's do this in a graph, right? What is the equation of the line? Okay, well, the slope is up 2 over 1, so y equals 2x minus 1 is our y-intercept. Okay, what is the average rate of change? Okay, average rate of change is slope, right? It's 2. It's 2. Now you could choose 2 points. So you could choose 0, -1, and then you could choose 1, 1. And so we could say y2, 1 minus -1, y2 minus y1 over x2 minus x1. So we can say this is 2 over 1, but we should already know it's the same as slope. Okay, what's the average rate of change from 1 to 5? 2, same as slope. What's the average rate of change from 2 to A? 2, because of slope. What do you notice about it, right? The linear function, the slope is the average rate of change. Okay, now, what about a curve? So how can the average rate of change be represented graphically, right? It's a tangent line. It's a line through the 2 points. So the dotted line would be the average rate of change. So a line that passes, secant line, right, means cut through, right? So a line that passes through those 2 distinct points is called a secant line. Write an expression for the slope. So this is y2, or f of x2, minus y1, or f of x1. Remember, f of is the same as y equals, right, over x2 minus x1. So what is the average rate of change over that interval, right? It's whatever this formula is, right? Like that's slope, right? That's average rate of change. Okay. 83, working with a partner, right? We're going to take turns explaining average rate of change. So we're just going to find these for each function. So we have 3 minus 2. Now remember, we have to plug these into f of x equals x squared. So 3 squared is 9, minus 2 squared is 4. So this is going to be 5 over 1, or 5. Okay, the next one, we have 1 minus 0.01 over, right? What's the log? So we have the log of 1. Sorry. That's 0. And then we have the log of 0.01. That'd be negative 2. So this is going to be 2 over. So this is 0.99, which is going to be about 2.02. C, we have 5 minus 2. And if you plug in 5 squared is 25. Times 3 is 75. And then 7 minus 75 is negative 68. Right? And then we'll plug in 2. 2 squared is 4. Times 3 is 12, so 7 minus 12 is a negative 5. So this is going to be negative 68 plus 5 is negative 63 divided by 3. That's a negative 21. Right, so hopefully you get the idea, right? And you get this idea of average rate of change in a function.